Astronomy Astro. In this Python tutorial on Astropy, a library used for astronomical purpose, our objective is to learn that how to mask a particular set of pixels in a fixed image. Okay, so your image may be galaxy or stars or other objects. So here the masking implies that suppose your intention is to remove your unwanted or bad pixels or pixels having low signal to noise ratio, also called SNR. So you want to remove and you don't want to include your analysis of your image or your photometry of the objects. So we need to remove these bad pixels. So uh, in order to do that, this tutorial may be helpful. Okay, so let's understand with the image. So here you can see that I have a fixed image, and you can see here I have some sources, right? Star or galaxy, right? And here you can see that as you move through the images, like there are some value of the intensity at each pixels, and you can see the white pixels. White pixels I have masked already. Okay, so you can see here inside this pixel there is no value. Okay, so there is it means that the pixel has been masked and it has been excluded from your photometry or image analysis. So the same thing we have to do it using a Python coding. So you can see I have masked more pixels here. So a single pixels we have a mask. Okay, you can see in this pixel there is no value. Okay, so same stuff we have to do using Python coding. You can see here I have masked a lot of random pixels, right? So same thing we'll be doing using a Python coding, Astropy, NumPy and matplotlib. So let's do it. Do this stuff using Python coding. So first of all, I will import some libraries. So I can import Astropy or maybe NumPy, first one. So NumPy, then I can import matplotlib for plotting, and after that I can import Astropy. So from astropy.io import feeds. Okay, so this will deal with our feeds file, right? So we have libraries, and so we have libraries. Then I will read my feeds file. Okay, so I have my file equal to feeds.open, right? I can give a file name. So in case I have this file name arco.feeds, right? And then I will get the file information. So where my image data is, right? So file information. So I can give here file.info. So here you can see that in your primary SDU, 0 stands for primary SDU, and you have like this dimension, row and column, and this is your image SDU. Okay, so I will then extract image data, right? So image equal to your say file and 0 for your primary SDU, right? So 0 for this 0, and then dot data, right? So this will give your image data. See here you can see that, and then I will plot it. Okay, so plot it, plot this image. So for that type your command plt.image show, stands for im show, and give your say image variable, right? And you can also give okay, now run it. So type here prt dot so, and you can also give here prt dot figure, right? Now run it. So here you can see that you have an image, okay? So here you have like a stars or galaxy, it may be. You can see the objects here, right? Or maybe you can also plot this image on the log scale, right? So for that, type here np dot log 10 and take, right? So here you can see that your image are looking perfect right now. You can also make origin 0 to consider the origin at the lower left. So origin equal to lower. So here you can see that your origin is not at 0 0. So if you do this origin lower, it will bring your origin at this. Okay. Now I will start the masking. Okay. So here, mm, or maybe you can plot on the another image. So uh, now perform masking of uh, pixels, right? So suppose I can give my say x coordinate say equal to, I can give say you can give here say mm, 180 or 180, or then you can give your say y coordinates, right? One y coordinates equal to you can give say your 200, right? And yeah, maybe you can give it say 300, right? And then okay, so now you can update your 2D image value. Okay, so for that, this is your masking pixel xy value. Okay, after that you got, okay, so now uh, update these pixels in image. Okay, so for that you type your image and give your y coordinates in initial. Okay, and then you give your x coordinate, and you have to give your uh, xy as a in the reverse order. Okay, in terms of image, don't give x and y. Okay, it takes yx and it gives value at x comma y. Okay, so I can say here image x comma y or y comma x, give value at image x comma y. Okay, so then you have created your image, right? And then you can give this uh, coordinates as a value in p dot uh, not a number. Okay, right? And then you can give here plt dot figure, or maybe you can just run it and then type here plt dot figure and type here plt dot uh, image show and give your image, right? Now run it. So here you can see that here your pixel value is not a number, okay, and around that the pixel has some values, okay. So around this pixel there is no value, means that your pixel has been masked, okay. So the reason of main thing that like this pixel is very bad, it has low SNR, or like you want to remove this pixel, so this way you can mask this single pixel, right? Now what I can do, I can like do masking for a multiple set of coordinates, okay. So for that I will define these coordinates in the for loop, okay. So I can define, or maybe you can import a random module. So import random, so like this will produce random numbers, and I will use this to produce your random coordinates, right? So I will go here, and then I can type here np dot uh, random dot rand int, okay, because pixels are integers. So I could go, and I can give say 1 to 1000, I mean the size of this x and y image size, and I can give say 50 pixels, okay. And then you have y coordinates, so just copy it, remove this single pixel, and then you can go from, say I want to go 100 to 200, right, and 50 pixels. So now run the code once again. Okay, so here you can see that this time you have got multiple pixels masked, okay. You can see this pixel is masked, there is no value inside that, and around that there's some values. So this way you can mask the multiple set of pixels individually, okay. So this is how the masking of individual pixel is done, okay. So I hope this picture is clear to you, that how to do masking of particular pixel or particular set of pixels in a fits image. So I hope you got the idea that how to do this pixel masking. So let's review the code once again. So I have imported some library numpy, matplotlib, astropy, and random module. Then I have opened the fits file. I have extract where my image is from this information file. Then I have extract data. Then I have plotted the data on the log scale, and I have done the origin lower. After that, I have chosen a set of pixels, random and individual pixels. Then I have set that pixel value to the data number, and then I have printed the image and plotted the image. So this is how my final image looks like after masking. One more thing, you may also save this image as a fits file. So let's do it. So save uh, mask image as fits, okay. So for that type here fits dot uh, write to, and then give your image, and then you can give your image and give your file name, right. So file name you can give masked pixel dot fits, and then you can give your header. So your image data, and header you can give here SDR, okay. So SDR you can define as here SDR equal to file 0 dot header, okay. Run it. So and you can see that this image has been saved. Okay, so go to media directory and check here masked. Okay, so you can see here masked. Yeah, so here is my fits masked file. Okay, so you can go and check it whether it is saved or not. So go to DS9, open it, and go to file section, go to my image directory, and here masked pixel repeats, open it. So you can see the same image as earlier one is appearing here. Okay, so you can make a zoom for, so you can see these are the pixel that has been masked. Okay, this is how it means that your image has been saved. Okay, thank you.